You are the founder of American River Nutrition and one of the foremost experts on vitamin E. So welcome to Modern Healthspan. It's very kind of you to join us today.
Thank you, Mr. Morgan. Looking forward to speaking with you on this vitamin E, and hope that your audience that faithfully listen to you may pick up something useful that they can use in their life. Thank you.
Thank you. No, I'm sure they will. So, Dr. Tan, so vitamin E is not one of the kind of most talked about vitamins, right? We talk about vitamin D, vitamin K, and C. So what led you to kind of dive into vitamin E and to spend so much time studying it?
It started with my career when I was a University of Massachusetts professor. This would be in the early 1980s. I was studying palm oil. And palm oil, when it's not processed, is orangey color. I was fascinated by the color. The color led me to vitamin E. Vitamin E is nearly colorless, like that. And so when I look at the carotene in palm oil, I noticed that the carotene does not easily get destroyed. That led me to discover the vitamin E in palm oil that protect the color. But of course, when people eat palm oil today, the color is bleached off, so they look more like corn oil color, like that. So the natural color of palm oil is more carrot color. So it's not it's pleasing to look at, but people can't cook with it, so they bleach it off. But if it's not bleached, then the vitamin E, which is what I discovered then in the 80s, that would protect the color from degradation. So that first took me into vitamin E. However, when I asked the institution that funded the study, they said, oh yeah, we know about the vitamin E, it's alpha tocopherol. Then I said, I fear not. So then I continued some study. Rather than finding one vitamin E, which is alpha tocopherol, the best known, I found 4 peaks in them, of which one of them is alpha tocopherol. Well, clearly the other 3 were not. So as a scientist, I was very curious. What were the other 3 things? And then when I looked at it further, it has antioxidant property. It actually looked very similar to alpha tocopherol, but they are not alpha tocopherol because there are 3 other peaks separate, identified. So when I did further research into it, I found out that it is a similar vitamin E compound called Tocotrienol. So now that leads me to define vitamin E. Vitamin E has 4 tocopherols. The tocopherols are the things that you commonly found in your cereal box, 100 milligram or 100 IU. So that would be the tocopherol. And then there are 4 tocotrienol. They are designated with the 4 Greek letters: alpha, beta, delta, and gamma tocopherols, alpha, beta, delta, and gamma tocotrienol. These are the 4. The difference, I'm going to take this molecule here. This would be an example of a vitamin E molecule. And this one here would be the antioxidant head that protects the lipid, make your skin feel better. Many of your audience probably know that. If I purposely go out of screen, this is the tail. You see, there is a hydrocarbon tail. The carbon is the black and the hydrogen is the H. If I put it closer to you, you see there's a double bond here, a double bond here, 2, and there's the last double bond here, 3. And hence the word trienol. En means double bond, trienol. Were this to be a tocopherol, the 3 double bond disappear. So the hydrocarbon tail is fully saturated, like we talk about saturated fat. But in a tocotrienol, they're unsaturated. So the unsaturated tail is a little bit shorter because of the double bond here. In the 1970s, there were a few UC Berkeley professors. They were curious. When they put tocotrienol and compared to tocopherol to protect fat, they noticed that the tocotrienol was approximately 50 times more potent. Now, 50 times more potent is a little bit insane. You would think that if something is more potent, it'll be 2-3 times more. 50 times is a little off, so they need to find a mechanism to explain why is tocotrienol 50 times more potent in protecting the fat from going bad. And this is how they found. All cells look like a bean shape, and all the constituents of the cell are inside, and then surrounded by it are the cell wall. And the cell wall are 80% lipid and about 20% phosphate. So that is important. People don't talk about this so much. Later, you probably ask me about senolytics, and it's not unrelated to this. So in this cell wall, if you think of a place to live, for example, like in Hong Kong, you have a lot of people, and you have to protect a space of the thing inside, and that protection is the cell wall. So the integrity of the cell wall protect the content inside. So I think of the cell wall as a gated community, and that gated community, I know I'm using a metaphor here, is not irrelevant. How sugar go in and out, it's gated, for example. And how salt or potassium or sodium go in and out of the cell is gated. Otherwise, the cell cannot function properly. So the function of vitamin E is to protect the lipid so that it would not get oxidized. So in a tocopherol, the tail is longer, which I said before. So it anchors deeper into the cell wall. So it would move around the cell wall like this. And in the tocotrienol, the tail is shorter and it will go around 50 times faster. So therefore, in 1,000 oxygen, we need oxygen to live. If that oxygen goes wacko, then the vitamin E will take off the oxygen and would not allow the oxygen to damage the fat. That's it. So tocotrienol anchors less deeply, spin around 50 times faster, and capture that oxygen radical so that to make that cell wall and gated community whole again. So that's it. That would be the very simplistic, and through the 40 years of my research have always stood up to the test of its protection of lipids.
Sleep is the key to your body's rejuvenation and repair process. It controls hunger and weight loss hormones, boosts energy levels, and impacts countless other vital functions. During the holiday season, it's easy to slip from our health routine and have more late nights and eat irregularly. In fact, drinking more than 2 servings of alcohol per day for men and more than 1 for women can decrease sleep quality by 39.2%, according to a study from Tampere University in Finland. But when the vacation season winds down, it's time to get back on track and focus on healthy eating, exercise, and above all, quality sleep. For my sleep, I take Magnesium Breakthrough by Biooptimizers because it contains all 7 forms of magnesium. I take it every evening and it helps me fall asleep, stay asleep, and wake up refreshed. Visit magnesiumbreakthrough.com/modern and enter code 10 for 10% off your order of Magnesium Breakthrough. Thank you for your support. So could you talk a little bit about why it's so important to have fat-based antioxidants? Because we have a lot of, right, we have like vitamin C and other antioxidants. Why is having a fat-based one so important?
Thank you. That is not all interviewer ask me that question. Richard, I'm appreciate that you asking me that question. I usually give this as an example. I live in the northeast of the United States, in the state of Massachusetts. So we have 4 seasons in a year like that. And now it's in the summertime. So in the summertime, we are in the 80s and 90 Fahrenheit. Sorry, I'm not using a metric system. So it's probably about 20 to 35 degrees Celsius. It is hot, like that. In the wintertime, it's opposite, less about 50 degrees or something like that. So if you put a stick of butter on a hot summer day out, if you go back within an hour, that off smell is fat oxidation. We have here what we call roadkill. I'm sure that phrase is not uncommon elsewhere too. If you drive past a roadkill, that smell is fat oxidation. So I consider that of the four classic things in our body, fat, protein, carbohydrate, and the fourth one people don't usually talk about, nucleic acid. We need a lot of nucleic acid we eat from meat to make our DNA and stuff like that. We have it all. If we eat too much meat, then we have a stone, a kidney stone, and gout. On our foot. That's because of too much of this kind of uric acid. Otherwise, these are the four groups. Of this four group, we don't want our nucleic acid to be oxidized, neither a carbohydrate like A1C, neither our protein, oxidized protein is no good. And then the last one is fat. Of this four group, fat is the easiest, lowest line food to be oxidized. So I care about that most because everybody and their grandmother talk about an antioxidant. So if you want to cut the noise off, is what are the antioxidants to protect the fat from oxidize? Because it's the easiest thing to go bad of all the four major groups. And tocotrienol, as in vitamin E, will be the best way to do this. And if the audience is really gung-ho on this, there is an Austrian professor, I think his name was Hermann Bauer. In the 1970s, he was very fastidious to figure out. So he captured all the cell wall and he extract all the antioxidant from the cell wall of the human cell, and then he laid out. And when he laid out, 90% of all the antioxidant in the cell wall are vitamin E molecule. The remaining less than 10%, they are carotenoids, hence fat look a little bit yellowish color, carotenoids and CoQ10 and small smidgen of other things. You will not find vitamin C there because you mentioned vitamin C is in the water soluble phase and the cell wall is lipid soluble. And so if you care about the lipids to be protected, which is the easiest thing to go bad, then the cell wall is the best way to capture it. And 90% of all the antioxidant on the cell wall is vitamin E. Now, having said this, I'm not implying that if somebody that you interview talk about resveratrol, I am aware of a lot of this polyphenol, quercetin, EGCG in green tea extract, they are potent antioxidant, but they do not hang out in the cell wall of the cell where it matters the most when the gated community need to be protected. So that's the reason.
Excellent. And that's really interesting because then you need like multiple antioxidants. You can't just rely on one.
Correct.
So where can you find this tocotrienol as opposed to the alpha tocopherol? I mean, where does it come from?
In nature, I assume that your question is in nature, where do you find them? I have looked, Richard, high and low throughout my 4 decades of doing this research like that. I found them in many places. A little bit in olive oil, a little bit in coconut oil, pistachio, macadamia nut, corn oil. All of them very tiny amount like that. So if you were to say relatively, this is at 0 level, you'll find this amount of tocopherol and this amount of tocotrienol, but they're small amount. So if you eat a Western diet, you typically may get about 2 to 3 milligrams of tocotrienol, and typically you may get about 10 to 15 milligrams of alpha tocopherol, relatively speaking. So, but I'm interested in trying to get this enough so that I can extract this, and this would help mitigate the chronic condition of our aging body. And that I've only found 3 sources. And the 3 sources are, and this will bring closer to the Asian context. One would be from rice. At Thailand and Japan, processed, they have a lot of rice. And if you take away the bran of the rice, the bran have a small amount of rice bran oil, and in the rice bran oil contain tocotrienol. So rice bran oil contain tocotrienol. Japanese tempura deep fried, they use rice bran oil. It's one of the well-kept secret. And Thailand produce a lot of rice bran oil like that. Not so much in the US. Second would be in palm oil. Now, many of us know palm oil is high in saturated fat, palmitic acid, so we try to avoid that a little bit. But palm oil has a fair bit of tocotrienol from palm tocotrienol. So I knew about this. I discovered it from palm in the early 1980s, from rice probably in the late 1980s. So the annatto, which is what I found, will come much later, in the year about 1990. So about 15 years later, because I happened to go to South America. So here, allow me to tell a story. The year was 1994. There was an ophthalmologist called Johanna Seiden in Harvard University. She discovered in the back of the retina of the eye, where the fovea is, and here is laden with a keratin called lutein and zeaxanthin. And then this is the lens here. It filters the blue light so that it protects the retina of the eye. So it's a kind of senolytics of aging of the eye, like that. And at the time, I was very fascinated with all things keratin. Remember, decades earlier, I discovered tocotrienol in palm oil that contain orange color beta carotene. So I was intrinsically very interested in carotenoid. So I heard about this lutein and zeaxanthin, and I knew the lutein and zeaxanthin was found a lot in the marigold petal. So this is the book that I wrote, and this is a younger me. If I get closer, those are giant marigold. And those marigold. So I did find when I went to Peru. So like that. So here is a chance finding. If you look at me, I'm an Asian, born in Malaysia, speaks Chinese and English. I cannot speak a word of Spanish. And there are a lot of this kind of phytonutrient in China and Southeast Asia, but that was not my fate. My fate was I was looking for lutein in giant marigold, and I went to Peru. And they took pity on me that this guy can speak English, but he can't speak a word of Spanish. But it was really there. I discovered this lovely plant, literally 30 feet away from my looking at the marigold plant. I saw this annatto plant. Interestingly enough, the annatto plant, the color is also a keratin. Like that, if you touch it, it stains your hand. So I surmised then that there must be a very powerful antioxidant that protect the color from degradation. I have thought of many things in life like this. Most of them come to a cul-de-sac. It just is a dead end. But this is one of the things that did not enter into a dead end. Why did I even ask the question that it would be an antioxidant? In the plant kingdom, where they produce this keratin, then keratin is one of the most unstable compound on earth. They are protected. If you make Italian sauce with tomato, the lycopene does not get easily destroyed. If you cook blanched carrot, the beta carotene does not get easily destroyed because they're inside the cytoplasm of the cell. Unlike the annatto picture I show you, you touch it, it stains you. You cannot stain your finger touching tomato sauce or touching carrot. So therefore, they are outside the cell. And if you think about this, were you to come to visit New England in October, where the foliage is at its splendor, for 2 to 3 weeks. Almost immediately after 20 days, everything turns brown. So it should tell you ample. Keratins are beautiful, but after 20 days or so, they completely get oxidized and the color is gone. And winter comes and the leaf falls like that. So all that to say, keratins are inherently unstable. So in the annatto, if it's still stable, so there must be a powerful antioxidant that protected. It was my surmise. I was expecting it to be a polyphenol that protected it, but it wasn't. It was a vitamin E molecule, surprising to me. And more surprisingly, it's a vitamin E molecule without tocopherol. And most surprisingly, it's a vitamin E molecule without tocopherol and only contain the two most potent tocotrienol vitamin E I have ever known in my entire life. Then I realized I cannot leave this field of vitamin E. I got to stay put with it and study. Fortunately, God allowing, I persisted, and I've done many animal study and human study, which I'm sure your audience love to hear, particularly in the last 10, 15 years. And I'm thrilled, And in another month, Richard, I'll be 70 years old. I will stick around as long as I could, but some younger folks, young stallion and other young men and women should take this on and do more research like that. But until then, I want this whole field to be mature and bring the science to the layperson so the layperson can use the information distilled from the plant kingdom for the human benefit.